Hello again, lovely viewer. In the last part we saw how FLATTARDS can't even get basic naked eye observations of the positions of the stars right, and how they think the Sun is a flying spotlight. We also saw how, as with the stars, FLATTARDS can't get the altitude angle of the Sun right either, nor where it rises and sets at the equinoxes. In quantifying their altitude angle errors for solar noon at the equinoxes, we also found that maths itself offers striking clues as to which orifice FLATTARDS get most of their ideas from. In this part we're continuing our examination of the flying spotlight idea, which FLATTARDS seem to think is plausible due to a crippling lack of basic mental faculties. Let's go. So we looked at the FLATTARD flying spotlight circling above the flat Earth using the equinoxes as an example. But what about the solstices? At the June solstice the Sun reaches its most northerly angle for all observers, giving the longest summer day for northern observers at mid-latitudes and the shortest winter day for those in the southern hemisphere. At the December solstice the opposite is the case. You don't need to be told why, but FLATTARDS do, so let's run through it. At each solstice Earth's rotational axis is aligned towards the Sun. Since the tilt of said axis is 23.44 degrees to the orbital plane, the most northerly latitude at which the Sun can be overhead is 23.44 degrees, being the Tropic of Cancer. And if FLATTARDS have been paying attention, they'll be unsurprised to hear that this occurs at the June solstice. Correspondingly, the most southerly latitude at which the Sun can be overhead is 23.44 degrees south, and we're unsurprised, even though FLATTARDS may be baffled, to hear that this occurs at the December solstice. A simple conclusion arises from this. At the December solstice, everyone outside the Arctic and Antarctic circles can record the noonday Sun at an altitude angle appropriate to their latitude. 6 months later at the June solstice, they can do the same. The difference will be 46.88 degrees. But what should happen on a giant communion wafer created by a pan-dimensional thaumaturgist and illuminated by a flying spotlight if its inhabitants were to try this simple observation? Well, let's find out. They'll have to agree that the most northern and southern latitudes at which the Sun can be directly overhead are the tropics of Cancer and Capricorn. And they've told us that their flying spotlight is 3,000 miles, or 4,800 kilometers, above their space biscuit. First up, we'll need to know how far away the tropics are from the equator, so we know where the Sun will be overhead at the solstices. As we found last time, the distance from the poles to the equator is basically 10,000 kilometers. We divide that by 90 for each degree of latitude on the flat Earth, and multiply by 23.44. For FLATTARDS, the tropics, then, are 2,604 kilometers from the equator. Our equatorial observer will see the December solstice Sun 4,800 kilometers above the Tropic of Capricorn, 2,604 kilometers away. The alert among you will already see that this isn't going to end well. Using our old chum the tangent formula, we find that Mr. FLATTARD should see the noon Sun 61.5 degrees above his horizon, or 28.5 degrees from his zenith. This is already wrong, as we know that he should see the Sun 23.44 degrees from his zenith. Since the Tropic of Cancer is the same distance from the equator, our feckless FLATTARD will also see the June solstice 28.5 degrees north of his zenith. So the angular difference between his observations should be 57 degrees, rather than the 46.88 that reality prefers. We don't need to do any more to show that FLATTARDS are imbeciles, but if you're going to do a job, you should do it properly. Let's calculate the angular difference FLATTARDS should expect to see for every degree of latitude on their space pizza. We use the tangent formula every time. The only thing to watch out for is that between the tropics the angular difference is the sum of the angles from the zenith, and beyond the tropics the angle is simply the difference in altitude angles. Don't blame me, blame the FLATTARDS. Crunch the numbers and we end up with this graph. Now would be a good time to remind ourselves that in reality, wherever you are, the difference is always 46.88 degrees. So let's add reality to the graph. Oops. Nobody familiar with tangents of angles, which is simply the ratio of the opposite and adjacent sides of the triangle, should be surprised at this. It can never give a straight line. it is simply fundamentally impossible for the flat Earth to match what is really observed. The explanation favoured by those of us who aren't wedded to their conspiratorial insanity is that Earth isn't flat, and that the very idea is complete bollocks. Let's go back to an equinox. We saw in the last part that to match basic observations of sunrise and sunset at equinoxes, the flat-width flying spotlight must create an illuminated area that nicely divides the flat Earth in half. This immediately tells us that the flattard flying spotlight has a lampshade. The equinoxes only happen twice a year, and strictly aren't days, but moments in time when the sun crosses the celestial equator, which is why day and night aren't quite of equal lengths on the equinoxes. For the purposes of this discussion, that simply doesn't matter. There will be 2 times per year when the flying spotlight has to illuminate Earth this way. Every day, though, it's daylight for essentially half Earth's surface and night for the rest. That leaves us with the question of what the flattard flying spotlight does for the rest of the year. Let's start with the June solstice. We've already seen that at this time the sun appears furthest north of the celestial equator. Due to Earth's tilt being 23.44 degrees, everywhere north of the Arctic Circle will have 24 hours of sunlight. The North Pole will be halfway through its 6 months of constant daylight, and locations on the Arctic Circle will be getting their only day of 24-hour sunlight. On the opposite side of the world, locations in the Antarctic Circle get their only day where the sun doesn't rise, and the South Pole will be halfway through its 6 months of darkness. On a spheroid, these things are easy to understand. Half of Earth is illuminated, half isn't. What does this illuminated area look like on a turtle-mounted space pizza, though? Let's unwrap a spheroid illuminated per the June solstice back out onto a flat Earth and see where night and day are. It's clearly different to the half-and-half illumination of the equinoxes that we looked at earlier. What does this mean for flatwidths? It can only mean one thing. The flattard flying spotlight's lampshade changes shape. For day lengths at different latitudes to match reality, this is the way the giant frisbee flattards think we live on would have to be illuminated. The magic lampshade changes shape to give us the changing seasons because reasons. Inscrutable reasons. Hey! As the June solstice passes, the lampshade returns to its equinox shape over the next 3 months, and then for another 3 months the sun heads south until we get to the December solstice. In reality, this is dead simple to understand because on the other side of Earth's orbit, its axis is facing the other way to the incident sunlight, so we have the opposite situation to the June solstice. This of course means that everywhere south of the Antarctic Circle has 24 hours of daylight, and the South Pole is halfway through its 6 months of continuous daylight. So let's watch the change in illumination from the September equinox to the December solstice on a flat Earth. You can see where this is going. It presents a problem for flattards because for them, the far south is a ring around their king-size god biscuit. That means that a single light source has to illuminate this ring thanks to the magic shape-shifting lampshade. Naturally, flattards have an explanation for this, and by explanation I mean a haphazard collection of blustering expressions of outright denial. They claim there is no 24-hour sun in the far south. Quite how they know this is still unknown because, according to them, nobody can go there, and since none of them have left their trailer parks, they haven't been there either. But they know there is no 24-hour daylight in Antarctica because reasons. If there really were no days in the year with 24 hours of daylight south of the Antarctic Circle, that leaves flattards fumbling to explain another aspect of their special little terrarium. How exactly does the flattard flying spotlight, with its magic lampshade, illuminate Earth between the September and March equinoxes? And what specifically happens when the sun is directly overhead the Tropic of Capricorn at the December solstice? Well, this is where they reach for their special pleading playbook, whilst pretending that ad hoc explanations have any value whatsoever. What they need to do is pull their fingers out of their arses and present a coherent physical model that explains the existence of a flying spotlight with a shape-shifting lampshade in the first place. It needs to be one that always produces a pattern of illumination, and hence sunrise and sunset times, at all locations on Earth and at all times of the year, that, by sheer god-bothering coincidence, are exactly what you'd expect from a spheroidal Earth with an axial tilt in orbit around the Sun. A simple system that any sky wizard worth its salt would have made in the first place.
Hey!
Until they have a model that can make the kinds of predictions that the rest of humanity has been capable of for centuries, there is no reason whatsoever to conclude that the idea of Earth being flat is anything other than delusional bollocks. In the next episode, we'll look at more ways that the idea of a magical flying spotlight doesn't hold up to basic scrutiny, as if being reliant on a magic flying spotlight wasn't enough of a clue in that regard in the first place. See you then.
Sei sotto un cielo sbagliato.